Hello everybody, my name is Kevin Atterbury.
Hello everyone, my name is Savon Nondan.
My name is Baba Mamouni.
My name is Elvin Bueno, and this is our senior project, the automated potato cutter. What I'm responsible for this project is the implementation of code used to run through Arduino. I've learned this through ELET 7404, Embedded in Real-Time Systems. I took it in the spring 2018 semester with Professor Nasri.
I'm responsible for the calculations and the design portion of this project, and I'll be implementing the mechanical system designs course I've taken 2 years ago.
And I'll be responsible for the general research of materials and the general research of the project all together. And with the knowledge that I have throughout the 4 years of college with the classes of fluid power systems, control systems, mechanical system designs, and mechanical design principles, I'll be implementing that into this project.
I'll be researching on the parts required and the bill of materials, and that directly corresponds with mechanical systems design, which is a class I took with Professor Tomasi here at Alfred State College.
So the purpose of this project, or the senior project for us, is to make sure that we have a virtual, hands-free potato cutter. With the use of pneumatics and program logic control, we will be able to achieve the potato cutter to be automatic instead of manually. It advances the process of cutting fries, and it reduces safety hazard in case people might have cut their finger off due to manual cutting of potatoes. It also reduces the times to cut potatoes into French fries. Brief history about French fries. It was cultivated by Peruvian Indians in the 200 BC. In 1621, it was introduced to North America. France and Belgium are claimed to be the originators of French fries. It was a very popular dish back in the 1600s as well. In the 19th century, it was introduced into North America specifically.
Manual potato cutters come in several types, and these are some examples. As you can see, this French fry cutter consists of a lever, a pusher, which pushes the fries against the blades, a pusher support, which is the groove in there that supports the pusher, and the blade, which cuts the potato. This is another design. It just has two handles that you just push together, and then they cut the potatoes. This is pretty similar to the first one that I just spoke about. As you can see, you just place the potatoes right on top of the blades, and then you just pull the handle, and then it pushes it down vertically and cuts the potatoes. This is a little different. This is called the Braun mandolin, and it was invented by a guy named Forel in the year 1930. It has multiple uses and can be used to slice a variety of vegetables, including zucchini, carrots, onions, and tomatoes. This is an example of an automated potato cutter, very similar in design to what we have. It essentially uses pneumatics to extend and retract the cylinder, which pushes the potato against the blade to cut it. There are several factors involved, such as how much force is required and what cylinder size should be used. These factors will be elaborated upon in the calculation section of this presentation. Next, we would like to show a brief video which will demonstrate how our design will function. As you can see, this is the blade. They come in different shapes, different patterns that cuts potatoes.
This is our multi-use air-powered cutter. It's now set up to do 3/8 inch French fries. Knives here, and the pusher plate back. Once the air is hooked up, you simply lift the hand, and the pusher retracts. At this point, you simply load the potato, and once you bring this forward and close it, it will push it through, and you repeat as necessary. And as you can see, perfect 3/8 inch French fries.
This just shows the different
Set
patterns
up
of
right
blades.
now for a 3/8 inch potato slice. You simply lift it, load the potato, and once we close, it'll automatically push it right through. Now, perfectly sliced potatoes. Nice and straight, no curve. Air-powered cutter set up to do a 4-wedge potato. Simply lift the handle. You can see the 4 wedges set up here. It's also available in 6 and 8. And place the potato, close the lid, and we'll get some wedges.
Okay, so let's talk about some advantages of the manual French fry cutter. Well, first off, since it's manual, there's no electricity required to operate the system. So therefore, the user would save money. Also, there's different designs and styles available, so it's very easily accessible to buyers. The assembly is relatively simplistic, and serviceability is very simple and inexpensive. Now, advantages of an automated French fry cutter. Well, since it's automated, you would have an accelerated production of French fries. Also, it'll be virtually no effort required to process potatoes into French fries, because the system it does all the work for you. And also, being that it's an automated system, there's no direct contact removing components, so which would eliminate personal safety. And here's a little computational analysis we've done. So first off, we had to size the cylinder that we're gonna use for the system. So we had to have a few criteria defined. One is force and pressure. Well, first we had to do some research on how much force it actually takes to cut a potato, and we found out to be around 60 pounds. Then we assumed a system pressure, because we're using pneumatics to operate the system, and we assumed a pressure of 80 psi. Now, we use the diameter equation, which is just the square root of 4 times the force over the pressure times pi. And we got an estimated diameter of 0.977 inches, which is approximately 1 inch. And we noted that we need at least a 1 inch diameter cylinder to operate the system. So we did some more research, and we went on Parker's website, and we got a list of different options available for us. And we selected the 1 1/16 bore. We found that to be suitable for the system because of cost associated. Then we back solved to solve using the selected cylinder size. We back solved for the force it will actually produce. And with a 1 1/16 inch Or we computed a value of 70 pounds, which meets or exceeds the system requirements. Thus, the cylinder can run the system.
For this project, we will be using Arduino. Specifically, we will be using an Arduino Uno. An Arduino Uno allows us to implement code into a specific integrated circuit that's on the actual board. We will also be utilizing a motor shield. This motor shield will allow motors to run in a bidirectional pattern, so we can move the machine back and forth if need be. Also, we will need motors for this system. As I stated, the motor shield will require motors. The motor purpose is for bidirectional movement. So as you saw in the video, we can move the piston back and forth to cut the potatoes and then bring it back to safety. Our finalized idea is the fact that when a potato is loaded onto the system, we will then check the distance between the potato and the actual distance sensor, which will be required as well. That will then translate into the amount of speed necessary to create the amount of force needed to cut the potato. As stated earlier, this will be the distance sensor that we will need. The placement of this distance sensor will be placed outside of the system itself. This is because we don't want the sensor to be in contact with the actual cylinders. The purpose of this distance sensor is to find out the distance between itself and the potato, just to generate what size of potato it was actually loaded on. Its detection, as stated earlier, will just see how much distance is between those two, and then therefore we can see the size of the potato. And as stated earlier, the force is dependent on the speed that we will be using to drive the piston into the potato, which will then therefore cut it. As stated earlier, this is my Arduino Uno. This Arduino Uno obviously has a lot of components on it, but this is the main circuit that we will be using. This integrated circuit will be manipulated with and used through Arduino IDE. Its purpose is to run a program, and that program will be used through Arduino IDE, through an Arduino language. This is the most basic and lowest level of code needed for this project to run. And it'll also be our main source of power, because this has a 5-volt outlet and also a power switch that is needed to turn on the system. Our Arduino code, as stated earlier, will all depend on the size of the potato that is actually needed. This size will determine the amount of delay that is needed on the system itself, and the amount of force that is needed to then drive the piston into the machine. Our overall concept, as stated earlier, is that our delay will coincide with the size of the potato, which, if a bigger potato is loaded onto the system, it will create a longer delay in order to generate more speed to then cut the potato. However, if a smaller potato is placed in the system, a smaller delay will occur, and then therefore not allowing so much force to then cut the potato in half. And we will display our Gantt chart right now. So, as you can see in this Gantt chart, it is created in such a way where we can divvy up and divide our semester or our weeks into times that we can meet with each other. For example, if we switch to week 10 of this project, and if we scroll up a little bit, we'll scroll back down, we can see that this pink area right here, you scroll up a little, this pink area right here is the design process, and we are in this design process right now. So far, we are 30% done with this. Our initial design is 50% complete because we need to fine tune it, make certain tweaks to it. And as you can see, we have other things to actually go through. Our design revision, our written report, and our actual presentation. You just scroll, keep scrolling. These are other sections right here so far. So this section actually includes our code, and our code can be used and troubleshooted throughout any manner that we need be. And our troubleshooting is actually a bar that goes all the way across because we will troubleshoot the entire time for this project. And this last section right here, this last cell, just states that our Gantt chart, as of right now, our entire project is only 36% completed. So, our conclusion with this project is that we've been using our basic knowledge that we've acquired through certain courses such as MEC 4224 and ELET 7404. These are required classes that we learned through our major, and we've been utilizing this knowledge that we've gained in order to create this automated potato cutter.
And as Alvin said before, we use the knowledge that we've learned throughout the 4 years of a college course to implement all the skills and techniques that we've gathered up all together to come up with this project and all. And these are just some of our references for the photos and the information that we got on the automated potato cutters. And that is the end of our presentation. If you have any questions, you can make comments below on the link. Thank you.